In today's note, we're going to be looking at the energy flow in an ecosystem. So we've seen this before. That's a pyramid of basically the hierarchies or the different trophic levels in an ecosystem, similar to our food pyramid or food chain. We see the producers or the plants at the bottom, primary consumers, so these would be herbivores that feed on the plants, secondary consumers that feed on the primary consumers, and then tertiary consumers, which feed on the secondary consumers. So this is going to be important to know for this note, because it's going to show how the energy changes as we go from one level to another. So in the first law of thermodynamics, what I want you to do is just take your hands and rub them together really fast, and then press them against your face. And what do you feel, or what happens? So basically the movement of your hands together as you rub them, and then as you put them against your face, you should feel that your hands are now warm. So basically, what the first law of thermodynamics states is that the energy, or the energy in general, cannot be created or destroyed. It just changes forms. So if you think back to rubbing your hands, that physical movement or that energy of your body, rubbing your hands together or moving your hands together, it takes that energy and changes it into heat, or heat energy, when it touches your face, or just when they rub together. So this means that all living sources, or all living things, must have a source of energy. And the ultimate source of energy for most living things is the sun. Right? Again, we go back to looking at the carbon cycle and photosynthesis in plants, where they use the energy from the sun to produce nutrients in themselves. So that's where the main source of energy is, because that's where the producers get their energy, and they're at the bottom, or they're the base of our pyramid. The second law of thermodynamics states that at every energy transfer, so every time we're changing or transferring energy, some of that is lost to heat or moving to cooler objects. So basically what we're doing is every time there is an energy transfer, some of that energy is lost. So in an energy transfer in food pyramids, energy is lost each time an organism eats another. So as herbivores eat plants, they don't get all the energy from that plant. Some of it is lost. Same thing as something eats a herbivore. Some of that energy is lost. They don't get all the energy from the organism. So each level gets 10% of the energy from the trophic level below. So they're only getting 10% of the total energy that's in the level below. And 90% of the energy is used by organisms to stay alive. So basically this is where the difference is. So if you look at plants, they gain energy from the sun. 90% of that energy is used to keep itself alive, and 10% is what the level above can obtain or access when it gets eaten. So if we look at an example here, let me get my little laser pointer. We see our producers at the bottom. So they gain energy from the sun. They use about 90% of that energy to kind of sustain itself. The rabbit, which eats the grass or the herbivores, only gets 10% of that. So they only have 10% from the original. So here we have 10,000. So here we have 1,000. So 10%. And then only 10% of this is gained by the secondary consumer, or the snake. So they only get 100. And then the snake uses up 90% of that. And then the other 10% the eagle can get, which comes from where we see the 10 up here. So again, we see that energy, that extra energy being lost as heat, or it's just being lost as just the organisms sustaining themselves. So you don't get all the energy that the previous level has, because they need to use some of that, or the majority of that energy, to keep themselves alive. Here we just see another example. So again, we have our producers down here. They're at 1,000 in terms of energy. And then we have the primary consumers. So they get, again, 100 or 10% of that. The secondary consumers get 10% of that 100. And the tertiary consumers get 10% of this 10. So again, it decreases at every level because again, those organisms need the 90% to keep themselves alive, or it's lost as heat or whatnot. So in our energy pyramids, the movement of energy through an ecosystem can be summarized by an energy pyramid. So we just saw two examples of those. And since we lose energy at each trophic level, each step up on the pyramid gets smaller. So basically, because there's less and less energy available for the organisms above, there's not going to be as many of them. So that's why each level gets smaller. And then energy is measured in either joules or kilojoules. So just basically just a unit of measurement. But again, here we see a third example of an energy pyramid or a food pyramid. And because energy is lost at each step, this sets a limit on the number of trophic levels to about 5. Right, so we see here we have our sunlight, then we have our primary producers that again get 10%, then we have our primary consumers that get 10%, secondary consumers that get 10% of the previous, and the tertiary consumers that get 10% of the previous one. Right, so again, it's the same idea in the last two examples that we saw. We have a large at the bottom and it decreases, it gets smaller because there's less energy available. So again, there's less energy available because there's less energy available, that means there's fewer organisms that can survive at that level. Right, if you look at this, if you look at the hawks in the tertiary consumers, there can only be so many hawks because they need to consume a large number of mice or rodents to get enough energy for their bodies to survive. So you can only have so many because, again, the amount of energy available to them is low. That's why you'll see more herbivores or more insects because, again, they have lots of energy or lots of plant life to gain that energy from. So to control an ecosystem function or control on ecosystem function or how an ecosystem functions. So there's two types. We have the bottom-up control. So this is the hypothesis that states that primary consumers ultimately control ecosystem function. So looking at this, what this means is that because the primary consumers gain the energy from the plant life or the producers, basically what it's stating is that they control whether the ecosystem functions or not. Because if they're not getting enough energy, then that means levels above it cannot get enough energy. So they're basically that kind of safeguard or that control. And we have then the top-down control, which is that predation at higher trophic levels ultimately control ecosystem function. So this one is stating that the predation or the predators at the top, they eat or consume the animals in the trophic levels below, which limits how much they can consume from the level below it. So basically, rather than the herbivores or the primary consumers setting a level for how much can exist above it, we're saying, or this one's stating that the predators at the top eat or consume the organisms in the level below it, which limits how much they can take from the bottom level, which kind of keeps it in check. So those are the two basic or two hypotheses for how you can control how an ecosystem functions. So again, just a quick note, but basically looking at how energy flows through an ecosystem, looking at the energy or the food pyramids, and basically understanding that the energy decreases as you go up the food pyramid, and only 10% of the previous level is available to the one above it.